photocells would look like as components as we'd buy them in electronics, and a lot of the devices that we might buy have photocells embedded in them, as you can see through this little window right here and this little window right here. And there probably is some electronics on the inside of both of these things then that in turn would turn on and off something that you'd have connected to it, like something plugged into this, like tree lights, or maybe over here a light bulb that would screw into it. Currently, this is the circuit that you're likely to have connected on your breadboard. Keep it connected. You can use the LEDs for some other things later. Really, we're just going to need to add a couple additional parts, but we're going to do it on the very end of the breadboard out over here. If you did rip everything out of there, that's fine. You can simply build the circuit that is required right here. And if you need to add the LEDs back in later, you could just simply add as many LEDs as you want right back in this area, and they'd be connected the same way that you'd see them connected in here. And they're using ports D2, D3, D4, D5, and D6. And if you follow the wires back, you can see the LED that they light up. D2 ends up connecting to this LED out here, and D6 ultimately goes way out here. Because I currently have this set up on my breadboard, I'm just going to continue to add on to it. And so what I've done, if you're looking to compare what you have to mine, I have the photocell that's been added, the resistor that I put in here. This is a 10,000 ohm resistor, brown, black, orange, and gold. And I added a jumper wire from here over to where it says 5 volts. And I added this wire here, which is right between these two parts, and it goes over to port A0. So unlike something that's digital, this photocell here is an analog device. More or less what it can do is it changes its resistance when it becomes lighter or darker, or when it sees a difference between light and dark, or anything in between for that matter. So the resistance varies. It's set up in a way here to make something what's called a voltage divider. It uses this part and this part. A voltage divider is something that we could learn about, or that you would learn about in a future electronics class. But the long story short is what happens between these two is that when the light changes that hits the surface, the resistance changes. When the resistance changes, it also changes the voltage that occurs right here. And if you look at where this wire is connected to, it's connected up to port A0. So more or less, when I'm covering or uncovering this, yes, I'm changing the resistance of this, but I'm also changing the voltage that this port is seeing. So what we need to actually be able to do is to translate the amount of light that's hitting this surface into something tangible that we can make decisions with, which would be a number. So the way the Arduino is set up is that it'll look at this port right here, and it'll change whatever voltage is coming in into a number between 0 and 1023. So whether 0 is bright or dark, well, we'll find out. But it'll be one or the other. And 1023 would mean that it is either bright or dark. We'll have to find out. But we do know that if the number were right in the middle, like about 500, 512 to be exact, we would have equal amount of light and dark, or it'd be right in the middle. We're going to get into our Blockly Arduino editor, and we're going to be able to pull in some blocks that'll help us so that we can see what number that we actually have in real time based on how much light is hitting the surface of our photocell. So once you get to Blockly Arduino editor, and don't do this now, just watch right now, but we'll pull the bricks in, or I should say brick, it's actually right here, serial. Okay, so we have several different options, but what we want to do is grab this one. Difference between these two. Well, I'll point it out when we're running and looking at the actual numbers, but we want the one that has the serial print LN at the end of it right here. This brick here we can throw away. We're not going to need that one. Maybe I should talk about what that brick would do. We could actually have it print something on the screen if we wanted to. In fact, here would be a good time to actually show what the serial print does versus the serial print ln. Here, if I type something in, I can say like the brightness is, and I'll just put a space or two there, and I'll just leave that for now. So when we're looking on the screen, it'll say the brightness is, and then when it does this next brick, it'll be able to figure out what the brightness is, and it'll print that number right at the end of this little statement. If I used this brick, if I use the print ln, that would be equivalent to pressing the enter key on the keyboard, right? So if I were to have used print ln with this brick right, or this brick and this brick together, then what it would have done is after it printed these words, it would go to the next line and then print the number. So we'll do it like this so that you can see. So it'll print this on one line, and we won't use an ln, and then immediately after it'll print something here at the number, which we'll get in 1 second, and that's now. So click on this arrow right here when you get in, and you'll click on analog. That is what we're going to be looking at, is the photocell. We want the analog read, and it is already at A0, and that's all I need. So I have these two bricks. I'm going to go grab my code, and I did notice they, at least on mine, they have this feature I can click on copy to copy the code. If you don't have that feature, you'll have to do it the old-fashioned way. Highlight it like that, and then right-click copy. Okay, so we want that, and then we're going to go back to our Arduino editor and erase everything, paste that in. Now notice this number right here. It's 9600. And I want you to just keep that in mind just in case, well, yours shouldn't be different, but we'll need to just double check something. So pay attention to that number. Go ahead, make sure that you're connected. If you haven't done this recently, it should say Nano, it should say AT Mega 328 old bootloader, and select the COM port after you have your USB plugged in. Let's upload. I'm saving it for the first time, so whatever, call it whatever you'd like. All right, it is compiling and uploading. And as soon as it says done, what you can do is come up here to the upper right-hand corner of the screen, and when I hover over this, it says Serial Monitor. Click it. Okay. And remember I said to look for that number 9600. So if you don't see anything, or maybe you see gibberish, see if I can give you an example. Double check and make sure that you have this set to 9600, and then these can say no line ending, and clear output will just clear the screen and start over. All right, now also here you can see the example where I typed in the brightness is, and the number gets placed directly after it. If it were printing it underneath, it would be a mess. In fact, if you want to see what it would look like real quick, take out that re-upload real quick, and I'll show you. Gibberish. We're back to our original setup right now, where I have the program that is actually showing the numbers on the same line as the statement right here. So we can get an indication of how bright it is in here right now. It's about 180, and I just have a desk light on right now. And if I shade this, then we'll see whether the number goes up or down. So the number in my case is going up. So what's happening is, as I cover it up, this wire is becoming more positive in voltage, and as I cover it, then the number goes up, and that's really what I need to focus on. Is I cover it, numbers up; uncovered, the number's there. So I'm going to need some number at which we succeed, that we turn the LED on. So you have to determine where that is. So I can start to slightly cover my hand over it, and that number will go up, and just pick a point. I'm going to use 300. So when the number goes over 300, I'll have it turn on the light. So going back to our Blockly Arduino editor, These 2 bricks, they could stay in. That would be fine. I'm just gonna put them off to the side right now. So we know what our number is that we wanna make a decision based upon. So the bricks we're gonna need are the logic, if, and we're gonna be needing analog, where we're gonna need to be reading the input so we can make a decision based upon it. We're gonna need to use another logic brick, and then we're gonna need to do something, which will be to turn LEDs on and off. So we'll pick some digital rights right here. And we're going to change that right now to 2 because we're using the LED. Let's make that a low. We'll have it do something when it's true. Well, actually, let's keep it high. And we'll see what happens here. I'm also going to change this to add the else. Okay, because I either want it to have the light on or high on port 2. 2 is where the red one's connected. Or else I want it to be off. Okay, so 2 is the red one, high means it's on, 2 is the red one, and it means off here. So now what decision do we want to make? Well, we want to see whether or not the number that is on port A0, that's where the photocell is connected to, it's going to read that port as soon as it gets to this brick, and it's going to look to see if the number is greater than, we said 300, so we need to go grab our math number, pull it in, whoops, and let's change that to 300. Okay. Now, if you want to see where these could tie in, we could put it right here. Or actually, yeah, let's see. Yeah, we'll put it right there at the end. And then every time it does this brick, it'll look and check. If it's greater than 300, it'll be darker, so it'll turn on. Okay. But if it weren't greater than 300, the statement would be false, which would mean it would do the else. So it would turn off the LED, and then immediately after it did either this or this, it would have to do these 2 things. Then it would come back up, do this brick, make the decision where it would either do this or this based on if this is true or not, and then it finishes with these 2 things. So every time through it will print what the number is on the screen so we can see it. So if we go back to the Arduino tab, I'm going to grab the code, and then we'll paste that into our Arduino app and upload. Okay, it is done uploading. So right now, let's see, I'm going to open up my serial monitor so you can see that, and you can also see this. So I'm going to start shading it. You can see it enter the shade. The number's changing, changing, changing. It just exceeded 300. Now the light is in fact on. So 300 was that cutoff, and now we know how we can make different decisions to do different things. Before you go off on your own, we're just going to do one more example, and it'll just be the do. So I'm going to get rid of the else out of there. And so I kept these bricks from the last one that I worked on. So what we'll do in this one is just make something happen a certain number of times after the light gets to a certain level. So why don't we do this? Let's make it so that when the light is less than 300, so that's going to have to be getting pretty bright. Actually, let's set it to 100. Okay. The light in my room is around 180 right now. So when I cover it, it'll go up. And when I give it more light, the number will go down. So I'll make an indicator that'll flash 5 times when it starts to get bright. Okay, so here's how it will work. Right here, it is checking then to make sure that the input number is less than 100. And if it is, I'm just simply going to do something 5 times. So I'm going to go to loop. I'll bring this one in right here. I'm going to change that number to 5. And if I wanted the lights to blink, or a light to blink 5 times, I just simply have to make it turn on. So I'll use a digital right. I could use a delay I'm going to use a delay of a second. And then I'll just duplicate this brick and duplicate the delay. Make sure that I turn the right LED, so number 2, that'll be the red one. We'll have it on. It'll wait. Then we'll turn the number 2 LED off, and it's number 2, and then wait, and then it'll do it again. After it's done 5 times, it'll come back out here. It'll check to see what that number is. If it's less than 100, it'll again do it 5 times. Okay. And I want to show you the difference here as long as I'm here. Let's switch these things. Uh, when you're done, try this. Switch the high and low. So make this one high and this one low when you're all done, and try that on your own and see the difference between that. Okay, go ahead, grab the code, and let's give this a shot. Okay, and done uploading. So we need to get more light on this. So I'm just going to incrementally turn this up and hope the number gets to, there it is. Ooh, it's right on the 1, 2, 3, 4, and 5. Yeah, so right now I've kept the light where it is. So the number must be below 100 right now because it's continuing to flash. So maybe if I turn the brightness back down after it finishes whatever number it's on right now for 1 through 5, it'll hopefully stop. And possibly, nope, that was it. It shut off. I was thinking maybe the screen light affected it, but there it is. So number gets higher, or I'm sorry, under a certain level, turns on that light 5 times, and then after 5 times, it checks again.